Welcome back. We are now in section 6.5 where we are doing a review of the formulas for the sum of perfect cubes and the difference of perfect cubes. You'll notice that the formulas are written at the top of the page for each of these. Please feel free to stop the video at any time to stop and copy these formulas down. You will need to have these formulas committed to memory for the purpose of the test, and you will be assessed on them. And because this is Math 95, you're not simply going to be given the sum or difference of perfect cubes and asked to factor them. They will be embedded in problems where you have to simplify them in rational expressions, as is what is required for Chapter 7. So this is only a review. But there's one thing I think that's worth discussing here is that these formulas are incredibly similar. So what is the difference? The only difference in these two formulas, and if it helps to write this down a second time for yourself, please do. You can stop the video. Is we have the plus sign here and the minus sign here, and the minus sign here and the plus sign here. So when it's the sum, it's positive. When it's the difference, it's negative. But if this one's positive, this one better be negative. And if this one's negative, this better be positive. So I can't think of any good tricks out there to help distinguish the difference between these two. If you know any, please pass them on. I am all ears. Share them in class, and we'll see what we can do. So we're just going to take a look at a couple of examples of each of these to illustrate this point home. And you can always ask questions in class if you want to inquire further about this. Usually the types of problems you're going to encounter with the sum or difference of perfect cubes when you're simplifying rational expressions aren't going to be terribly difficult. But we will pick one of that's fairly straightforward and maybe one of moderate difficulty, as we've already seen some of these in class. So let's just take a look at one example of this, and that's going to be for question. Let's go to question 19 first for the difference of perfect cubes. So this is going to be 64 minus 125 x to the third. So sometimes this can be a little confusing because how we have to sub everything in. But it's really important to just kind of follow the formula lock, stock, and barrel, because there may be multiplication necessary with this sometimes. So we're going to say let a to the third be equal to 64. So if a to the third is equal to 64, that means that a is going to equal 4. Next, we're going to let the value of b to the third be the second term, 125 x to the third. So if b to the third is 125 x to the third, b is equal to 5x. So what we're going to do now is we're going to rewrite this, doing all the substitutions using the values of a and b we've obtained here. So the first one is going to be 4 minus 5x. And watch how we do this now. We have a squared, which is the quantity, and let me bracket this off. This is going to be important. We have the quantity of 4, which is a squared, plus the value of a again is 4. The value of b here is 5x, plus the value of b here is 5x. And now this has to be squared. So that's a real critical piece. So all I've done is I've just substituted in a minus b times the quantity of a squared plus a times b plus the quantity of b squared. That's why I put the parentheses around each of these substitutions. When the squaring, sometimes you can overlook something very easily. So let's take a look at how this part in particular simplifies. We will retain the 4 minus 5x. Not necessary to rewrite that in any other way. However, at this point here, we have 4 squared. That will be 16. Plus 4 times 5x, that's going to be 20x. And then when we have 5x squared, we square the 5, we square the x, that's going to be now plus 25x squared. And now, in the factors of 4 minus 5x times 16 plus 20x plus 25x squared. We now have the pair of factors that make up the factors of 64 minus 125x to the third. Let's take a look in an example of the sum of perfect cubes. Question 22. One I think that's perhaps a little simpler. 8a to the third plus 1,000. So again, we're going to follow the procedures of letting a be equal to the first term and b be equal to the second term. I know that a is also the variable in the problem. If you need to write this using different variables, go ahead and do so. But I'm going to go ahead and let a to the third equal 8a to the third. So a for this is going to be not 2b. I'm getting mixed up with my Shakespeare here. But a is going to equal 2a, as the cube root of 8 is 2, and the cube root of 8 to the third is a. If b to the third is equal to 1,000, then b is equal to 10. So I'm going to use the value of 2a and 10, and I'm going to work and put them into this formula. So I'll put this here. I'm going to create a parenthesis here where I've got the value of a minus the value of a times the value of b plus the value of b squared, and put all this in. So this is going to be 2a plus 10 times 2a squared minus 2a times 10 plus 10 squared. So all this is going to go in the formula, and I apologize for my paper curling up here, so please feel free to pause so that you can get this down nice and neat. So when I simplify this, I'm going to get 2a plus 10 times, and I'm going to go ahead and multiply everything. 2a squared is going to be the quantity of 4a squared, since I squared both the 2 and the a. 2a times 10 will give me negative 20a, and then 10 squared is going to be plus 100. So now I have my pair of factors that represent the factors for 8a to the third plus 100. Let's see if we can find a few questions that may throw in a few tricks to try to trip you up. So here's a problem. Not too difficult numbers, but does contain a little trap. 39. This is going to be 2y to the fourth minus 128y. So you look at this and you may realize that 2 and 128, they're not perfect cubes, nor is y to the fourth. However, we can first begin by factoring a 2 and a y as the greatest common factors. Once we do this, we end up with y to the third minus 64. Now, y to the third minus 64, very easy to factor. For a, we have y to the third. Or excuse me, for a to the third, we have y to the third. So a will be equal to y. For b to the third, we have 64. So for b, we're going to have 4. So I'm going to use my values of a and b to sub into this. So this is going to be 2y times y minus 4 times y squared minus, or plus, excuse me, y times 4 plus 4 squared. And notice here I'm not using the parentheses. The terms are pretty simple. Not quite as important to use them here, okay? But may have to use them from time to time. So simplifying this a little more, especially that last parenthesis, we'll get y squared plus 4y plus 16. And now we have taken 2y to the fourth minus 128y, and now we have all of the factors of this. We'll take one sum of perfect cubes, and we'll go ahead and factor that, and let's see what we come up with. Let's try something of t to the sixth plus 1. And let's see what happens when we go ahead and factor that. So a is going to equal t to the 6th, or I should say a to the 3rd is equal to t to the 6th. So a is equal t to the 2nd. B to the 3rd is equal to 1. Well, b to the 3rd is equal to 1. Well, b, that's also equal to 1. So don't let the simple things trip you up. So we're going to write this now as t to the 2nd plus 1 times t to the 2nd squared minus t to the 2nd times 1 plus 1. So I'll go ahead and put my parentheses back in for the substitutions. Not much place to trip up except for this little last part here. So when we write this in simplest form by cleaning this up, we'll get t to the 2nd plus 1 times t to the 4th minus t squared plus 1. A further note to add, had this been t to the 6th minus 1, the binomial factor you would have attained here would have been t to the 2nd minus 1. And t to the 2nd minus 1 would have resulted in being the difference of perfect squares, and then would have required some additional factoring. So, again, on My Math Lab, you will have access to several examples that will give you practice in this, and I encourage you to utilize those examples for your further knowledge.